Okay, so we were having some questions on homework from the Friday notes that dealt with beginning of proofs. So the questions that I saw, for page 46, 47 that people have been kind of struggling with are 13, 14, 19, 21, and 22. Again, I may not go through all of them completely, but I'm going to go through similar ones, and I may just kind of set you up for you to solve the rest, so at least you get a start. So let's look at 13. 13 talks about the coordinates of points L and X are at 16 and 40 respectively. N is the midpoint of segment LX, Y is the midpoint of segment LN. Sketch and find, and then they ask us to find things. The length of Ln, the coordinate of point N, the length of Ly, and the coordinate of point Y. So without a diagram, this stuff gets pretty hard to do. So here's L, here's X. And we are told that the coordinates are at 16 and 40. And then we're told we have a midpoint. Oops. He should not be that color. He should be black. And that midpoint is N. And then we're told that Y is the midpoint of segment Ln. So all this talk about midpoint leads me to believe we're going to be using the midpoint theorem that we talked about on Friday. So let's see what we can do. All right, so we've talked about in our notes before how you figure out the length knowing coordinates. So if we want to figure out the length of Lx, we would take the absolute value of the difference in the coordinates. And we would get 24, the absolute value of 24, which equals 24. But that, again, tells me the length. But now I want to deal with the midpoint. So that means the length of Ln, according to the midpoint theorem, is 1/2 the length of Lx. So that's going to be 1/2 of 24, which equals 12. Now 12 is this distance. 12 is not the coordinate. To get the coordinate of n, we're going to take 16 as starting point for L, and we're going to add 12 to it. So we're going to get 28. So that's where 28 comes from. Now we're going to repeat that process, but this time we're going to deal with Ln. So the length of Ln is going to be equal to the absolute value of the difference of 28 take away 16. So that's going to give me absolute value of 12, which is 12. And we know that the length of Ly is half the distance of length of Ln. So that gives me the absolute value of 6. Or sorry, just gives me 6. Now again, what that 6 represents is the distance from L to Y. It doesn't tell me the coordinate. To figure out where Y is at, I start at 16 and I add 6 to it, and that's where I get 22. So very easily now I've got all the answers that I need. For the length of Ln, that is the 12. For the coordinate of n, he's at 28. For the length of Ly, he's 6. And for the coordinate of y, he's at 22. Okay? Alright, now, the next one deals with similar idea, but this time it's with angles. So we're going to be most likely, if they talk about bisectors, we're talking about the angle bisector theorem, and sure enough, it sure does. It says that ray SW bisects angle RST, and the measure of angle RST is 72. So I'm going to approximate a 72-degree angle. Exactness isn't important. So this is R, S, T, and then we're going to get our ray SW. Okay? So we are told that the measure of angle RST equals 72, and since SW is a ray, that's going to tell us that the measure of angle RSW would be equal to the measure of angle WST, and both of them would be equal to half the measure of angle RST. So that's going to give us half of 72, which gives us the answer of 36. So each of these is 36. Okay. Then we are told that we have ray SZ bisects angle RSW. Okay, so again, we'll go to a different color here. We've got the measure of angle RSW is equal to, we calculated 36, and that the measure of angle RSZ would be the same thing as the measure of angle ZSW, which would be equal to 1/2 the measure of angle RSW, which is equal to 1/2 of now 36, which gives us 18. So each of these angles is 18. And then they talk about SR, which is the top ray of our original angle, is the bisector of angle NSW. Well, I see the SW over here, and so that means I don't have the N, so I'm going to have to create a ray NS. Remembering that ray SR is its bisector. So I'll just kind of put them over here. And that's our N. So remember, RS is the bisector, so we're going to be looking for this guy. And he's bisecting angle NSZ. Or NSW. NSW. So we're looking for that. Okay? Well, we already know what angle RSW is, because he's here. So he's 36, which makes this guy 36. Okay? So now we're ready to answer some questions. We were asked for the measure of angle RSZ. And we have RSZ is the blue angle 18 degrees. And then we're asked for the measure of angle NSZ. So NSZ, it's the purple 36. So angle addition postulate, measure of angle NSR plus the measure of angle RSZ. So measure of angle NSZ is equal to angle NSR, which is our 36. And then our RSZ is that blue 18 for a grand total of 54 degrees. Okay? So there's the first answer. There's the second answer. All right, let's talk about number 19, the proof. So here's an interesting proof. This is one you've never seen before, right? It's not a theorem that we're trying to prove. In fact, it's just an idea they came up with. And it says, if points A and B have coordinates of a, little b, with the b value being greater than the a value, and the midpoint M of that segment has the coordinate x, then x, so the coordinate, is going to be the sum of a plus b divided by 2. So basically, what this is telling us is a shortcut to figure out the coordinate. Because before, what we were doing is figuring out the length, cutting the length in half, adding that half value to an endpoint, the smaller endpoint, to get to the coordinate of the midpoint. So this is a faster way of getting that answer. So remember what our diagram looks like. Here's our A, here's our B, and our midpoint M. And then we have coordinates for them. And I'm doing this opposite to what the book showed. So he's A, he's X, little a, he's X, and he's little b. Okay? So this proof is a fill-in-the-blank kind of proof. And this is the kind of one of the proofs you'll see on a test. So I'm going to just go ahead and fill in all the blanks. And then we'll talk about the logic. So we're given the given that A, points A, M, and B have coordinates A, X, little x, and little b, respectively. That means in the order that the big letters come, the little letters correspond. And we were given one more piece of information, that b coordinate is going to be greater than the a coordinate. Next, they came up with this length of AM is equal to x minus a, and the length of MB is equal to b minus x. Third statement, M is the midpoint of segment AB. Segment AB. Fourth is segment AB, AM, is congruent to segment MB. And then they say, comma, or the length of AM is equal to the length of MB. And I'm going to tell you right now, I have a huge issue with this. And I'll show you what I'm going to do, how this would change on a proof. Then we have x minus a is equal to b minus x. And then they partially give us statement 6, where they have 2x equals, and we have to fill in the blank. And then they give us x equals a over b, or a plus b over 2. Okay, so in the original problem, oh, I'm going to do these in a different color, sorry. I'll tell you what, I'll do the numbering in black. Okay, and we'll do these in green. So we were told in the given that points A and B have coordinates little a, little b, and that little b is greater than little a, and the midpoint M, a segment AB, has coordinate x. So they just rewrote that differently in the first one. So that is honestly just the given. Okay? And then we look at the next one. Now, how they're actually telling us how to figure out the length. Well, this is one of the rare times when we actually have something that tells us that we can figure out the length of something, and that, remember, was that ruler postulate. That postulate 2. That's one of the rare times we'd actually use it. Now, M is a midpoint of segment AB. Well, if you go back, that's told to you in the given midpoint M of segment AB. So what they did is they took the given and they split it into two locations. They took one given and they took information from it. They took the second given and now we're going to get more information. So the key word in number 3 is midpoint. And we know that a midpoint of a segment creates two congruent segments. So to get segment AM is congruent to segment MB, that is the definition of a midpoint. However, that does not justify that the measure of AM is equal to measure of MB. That is the definition of congruence. So here's what needs to happen in a real proof. That needs to become its own step. That's going to cause there to be one extra step throughout the whole proof. So be careful of this because it does show up on the Chapter 2 quiz. I did not get to fix that prior to making copies. I caught it after the fact. I think this was one of original quiz that I gave, and back 10 years ago when it didn't dawn on me that I really should teach those as two separate steps. So please understand that if you ever see a statement that goes from congruence to equality, that's actually two statements smashed together with two separate reasons. Okay? Now, remember back in step 2, we said the measure of AM is equal to x minus a, and the measure of MB is equal to b minus x. And then in step 5, we have the measure of AM is equal to the measure of MB. So all that's happening is, for 6, is that they took step 5 and did substitution with information from step 2. So that's your substitution property of equality. And then we have to fill in something on the left. So we're trying to figure out how did they go from x minus a equals b minus x to 2x? Well, we want to get all the x's on the left side. We would add x to both sides, giving me 2x. If I want to keep that alone, I'm going to have to get rid of that a, so I'm going to add it to both sides. Now remember what my goal is, to get x equals a plus b over 2. So that means when I add the a to both sides, I'm going to put it in the front so that it looks just like what the goal is. So that is actually simple addition property of equality. I added the same thing to both sides. But I did it twice in a sense, but because it's the same reason, I showed both operations because I'm allowed to simultaneously get x's together and to get constants together. Now, this next step is up to you to decide how you want to do it. To get rid of being multiplied by 2, we can divide by 2, or to multiply by the reciprocal of 2, which is 1/2. So I'm going to go with division since that's what I've always done, and I'm going to call this division property of equality. Okay, now here's the gist I want you to grab out of this. This is now a formula that we can use to calculate the location of the coordinates of the midpoints. Not how far the midpoint is from an endpoint, but where it is. So that's what 21 and 22 are all about. So on 21 it says M is the midpoint of segment AB. Move my book over, sorry. T is the midpoint, oh wait a second, I missed one. Q is the midpoint of segment AM. T is the midpoint of segment QM. Okay. And it says if the coordinates of segment A and B are little a and little b, then go ahead and find the coordinates of Q and T in terms of A and B. So we're going to use this idea that the location of a midpoint is the sum of its endpoints cut in half. So that's going to be what we're going to use. So let's start with M. Where is M located? Well, M is located at the sum of its endpoints cut in half. So that's M now. A plus B over 2. All right, next we're going to look for Q, because Q, remember, is the midpoint of segment AM. So here's what we have to do with Q. We're going to add the endpoints, coordinates of the endpoints, and cut the answer in half. Now, what I've just done is created a complex fraction, and some of you last year had a little trouble with this, so let's think about it from a different perspective. Instead of writing it like this, write it like this. Okay, that's going to make it a little easier. Now, I cannot add a to a plus b over 2, so what I'm going to do is to multiply top and bottom of a by 2. So now I have common denominator, and now I'm at 1/2 times the quantity 2a plus a is 3a plus b all over 2. So when I distribute, I get 3a plus b all over 4. And that's where Q is located. So that's the first answer that they look for. So now he is at, you know what, I should probably, I'll do him in a different color on the bar there. How about that? So he's at 3a plus b over 4. Okay? Now they want me to figure out t. So again, let's use the second notion that we did with Q. Let's put the cutting in half this way. We're going to take the coordinates for t is going to be the 3a plus b over 4 plus the a plus b over 2. But I can't add if my fractions don't have the same denominator. So what I'm going to do on the second fraction is to multiply the a, the b, and the 2 by 2. That's going to give me 1/2 times the quantity 3a plus b plus 2a plus 2b all over 4, which gives me 1/2, and now I have 5a plus 3b all over 4. So the final answer is going to be 5a plus 3b all over 8. Okay? All right, we have one more to look at. This is 22. 22 says, point T is the midpoint of segment RS. T is the midpoint. So again, I'm just eyeballing these midpoints, but I'm trusting. We're going to trust what we're told, not what it looks like. W is the midpoint of RT. And Z is the midpoint of WS. So this one's a weird one. Okay, so now what we're trying to do is to find the following lengths in terms, if the length of TZ is X, then find. And so they said sketch a diagram and let WT be equal to, and I'm going to give him a new color, Y. Okay, so let's hold on. Okay, so I'm going to go ahead and write some stuff out, and then I'm going to go back and see if I can think of it from a different perspective. Now, we were told that T was the midpoint of segment RS. Okay, fabulous. We were told that W is the midpoint of segment RT. Okay, now that I can deal with, because in the hint it told us to let y equal the length of WT. So if WT is y, guess what? So is RW. Okay. Now let's go back to T being the midpoint of segment RS. Well, if half of that segment, RT, is 2y, I have y plus y is 2y, wouldn't TS be 2y as well? So if I know if a piece of it is x, wouldn't that give me 2y minus x? Okay. Does that sound reasonable? Okay. Let's see. Let me double check that I haven't done something faulty. Hold on. Alright, no, you know what? I want to think about this from a different perspective. Let's do this. Okay. So T is the midpoint of segment RS. And W is the midpoint of segment RT. And Z is the midpoint of segment WZ. So that's where I got myself held. I was thinking about T. Let's look at it from this perspective. So this segment, oops, let me get a color here. This segment and this segment are going to be the same. So if this segment is x plus y, doesn't it make sense that this guy would also be x plus y? Okay? Alright, so now we can go ahead and get some ideas down. Okay? So I have so if we go back to the original statement that T is the midpoint of segment RS, that would tell us the length of RT would be equal to the length of TS. Well, the length of RT totals up to give us 2y, and the length of TS is comprised of x plus x plus y. So I'm going to go back to regular colors, or black here. I got 2y equals 2x plus y. So if I subtract y from both sides, I get y equals 2x. So what that allows me to conclude is that this is the same as 2x, this is the same as 2x, this is going to be x plus 2x, or a total of 3x. Having all that, I can answer all my questions now. What's the length of RW? Well, y is the same as 2x, so we get 2x. What's the length of ZS? ZS is the x plus y, which we figured out was 3x. What's the length of RS? RS is going to be the 2x plus the 2x plus the x plus the 3x for a grand total of 8x. And D, what's the value of WZ? Let's see, WZ is going to be the y, which is 2x plus the x for a grand total of 3x. There you go. Hope that helped.